This is a relatively easier question if you have done the basic sections properly. So 12 will be 2 square into 3. So we need to find how many 2 squares and how many 3's will go into 54 factorial. If we check for power of 2, that will be 54 by 2, 27, plus 27 by 2, 13, plus 13 by 2, 6, plus 6 by 2, 3, plus 3 by 2, 1. And this comes out to 46, 49, 50. And that means 25 fours can go in there. And power of 3 will be 54 by 3, 18, plus 18 by 3, 6, plus 6 by 3, 2. And that is equal to 24 plus 2 equal to 26. 3's can go in there. So since 12 is 4 into 3 and you can get only 25 fours, highest power of 12 that can divide 54 will be 12 to the power 25. This is a good question. It touches on a lot of stuff which we have studied in the basics. In the question, what we have been given is that the number xyz has 2 factors. And then we are asked how many factors does the 6-digit number xyz have. What we need to notice first is that if a number has 2 factors, it is a prime number. Because the only 2 factors will be the number itself and 1. The other thing which we need to notice is that if the number can be written in the format xyz, it can be written as xyz into 1001. And we can just quickly see how that happens. If you multiply xyz by 1001, you will get the first number xyz, then 0, 0, 0, 0, 0, 0, and then again xyz. So you can write xyz as xyz in 2001. And since this number is a prime number, we can prime factorize the entire number into 7 into 11 into 13, which is basically 1001. Now we can count the number of factors that this xyz have, which will be 1 plus 1 into 1 plus 1 into 1 plus 1 into 1 plus 1, which is equal to 16. And this we got based on what we have studied earlier. If a number can be broken down into P, A, Q, B, R, C, where P, Q, R are prime numbers, then the number of factors it has is A plus 1 into B plus 1 into C plus 1. Here we have been given that a number n square has 15 factors, and we need to identify how many factors will n have. Now, we know that if a number can be factorized into prime factors in the format P, A, Q, B, R, C, then the number of factors becomes A plus 1 into B plus 1 into C plus 1, and so on. So here, the number has 15 factors. So 15 can be written as either 15 into 1, or it can be written as 5 into 3. And if it's written as 15 into 1, it's probably of the format P to the power 14 and then Q to the power 0. Or if it can be written as 5 into 3, it can probably be broken down into prime factors in the form P to the power 4, Q to the power 2, because then it will be 4 plus 1 into 2 plus 1. If the number is of this format, if n square is like this, then n would be of the format P to the power 7. And if n square is of the format P to the power 4, Q to the power 2, n would be of the format P square Q. And for the first case, the number of factors n will have is 7 plus 1, 8. And for the second case, the number of factors will be 2 plus 1 into 1 plus 1. And that is 6. In this question, n is a positive integer which is less than 29. And now we need to ask how many values can n take where n plus 1 is a factor of n factorial. So n factorial by n plus 1 should be an integer. One thing you can straight away eliminate is that n plus 1 cannot be a prime number, because then n factorial will not have n plus 1 as a factor. So if we start counting them, you'll come up with these numbers for n plus 1. And we'll include 29 also, because n can be less than 29. So n plus 1 need not be less than 29. So we have eliminated 10 numbers from here. Post that, to solve this question, you'll have to manually count. So we have taken care of 1, 2, 3 we haven't taken care of. So 3 factorial by 4 will not be an integer. So this is eliminated. 4 factorial by 5 we have already taken care of here. 5 factorial by 6 will be fine. And if you count a couple more, you will soon realize that there is no other number. So the only one which we need to add here is the prime numbers plus 4. So you have to eliminate 6, 7, 8, 9, 10, 11 numbers out of all the numbers which are eligible, which is from 1 to 28. So out of 28, you need to remove 11 numbers, and that will leave you with 17 as the answer. It's not an easy question. It requires a bit of counting, but is of the sort which can come in the exam. So you should practice such questions. In this question, 40 factorial is expressed in base 8 form, and we have to find what is the last non-zero digit. We'll take this opportunity to also see how we can convert a number from base 10 to base 8. So if you have 213 base 10, you divide it by 8 and you write the quotient over here and the quotient over here and the remainder on the side. And then you keep dividing by 8 till you get the final quotient which is below 8. So in this case, your number will become 346. Same way, if we had to convert 512 from base 10 to base 8, we'll divide it once, we'll get 0 as the remainder. We'll divide it again, we'll again get 0 as the remainder. We'll divide it again, we'll keep getting 0 as the remainder, and eventually we'll get 1 as the quotient. So the number becomes 1000 on base 8. So if the question were how many zeros would be there at the end of 512 when converted to base 8, you will just see how many times this number can be divided by 8. And since here it can be done 3 times, we'll have 3 zeros. If it could be done 5 times, we'll have 5 zeros. Now let us look at the question. So we have 40 factorial. We should just find how many zeros would be there at the end and what would be left after we remove the zeros. So that we know how to do. We'll just divide by 2, 2 square, 2 cube, etc. Or the shorter way to do it is like we divide by 220 and then 10, 5, 2 and 1. We have done it several times before in different questions. So this comes down to 38. So 40 factorial is 2 to the power 38 multiplied by the other numbers. Now 2 to the power 3 is 8. So 2 to the power 36 will result in 12 zeros. And then we'll be left with a number which is 2 square into the remaining numbers. So then since the number is 4 into a lot of other numbers which are not multiples of 2, when you divide this number by 8, the remainder you will get is 4. Any number which is multiplied by 4 will either give 4 as a remainder when divided by 8 or will give 0 as a remainder when divided by 8. But since it can't be 0, it will be 4. So the final digit will be 4. This quiz exposed you to a few difficult but good concepts on number system and factorization. Now we would recommend that you keep revising these questions till you know them by heart, as in you know each and every concept that is in there by heart. And the way to do that would be that you spend like 1 week or 2 weeks doing other stuff, but then you come back to these set of questions and solve them again. And this time you should be able to do the entire quiz in say 60 seconds or 90 seconds. And if you're not able to do that, you should again look at the solutions, again look at the concepts involved, and again come back after say 2 or 3 weeks. We at Learn Harbor believe that it's better to solve few questions properly than to solve hundreds of questions and still not have the confidence and knowledge to do the 101st one. So happy learning to you.